Up until this point, we have been looking at gas laws with two variables each. For example, the relationship between pressure and volume, and how to figure out a pressure or a volume if one or the other changes. However, there's a limitation for gas laws. You may, quite often, come upon gases where more than one variable is changing. Maybe the pressure and the temperature are changed, or maybe the pressure and the volume are changed, and you're looking for a resultant variable change. So how do we consider all of the gas variables at one time? We need a different equation called the ideal gas law, and it looks like this. Pressure times volume equals moles of gas times our gas constant times temperature. Let's take a second now to define our variables. P is pressure, and this will be in ATM. V is volume. This will be in liters. N is moles. It's in moles. So this is the amount of gas. It can be given to you in grams, and you have to convert it to moles. R is our gas constant, and I'll show you where to find that. And T is temperature, always in Kelvin. On your periodic table, in the bottom left-hand corner, you'll see what the R value is, 0.082. And it has a really interesting unit to it, liter ATMs per mole Kelvin. We're not going to worry about the unit, but this is the number that you need. You can only use this R value if you are doing your problem with the correct liter ATM mole Kelvin units, which is why it's important that you put them in the correct units. In using the ideal gas law, you can look at multiple variable changes at one time. So let's say you have a gas at 2 ATMs in a steel container that is 4 liters at a temp of 298 Kelvin. How many moles of gas are there? Because all of these things work together, and you can solve for different variables here. So we would put it into our equation like this. 2 ATMs times 4 liters equals N, that's the thing we're looking for, times our R value, which is our gas constant, times 298. And so to solve for this problem, we'd isolate N. And in doing so, we isolate N, and you'll get 0.327 moles. You can do more complex things with this ideal gas law. Some points you'll be given a chemical equation, like the formation of water. And the problem may say that you start with a certain amount of grams of oxygen, and under various conditions, what would the resultant pressure be, etc., etc. So there's a lot that we can do with that.